Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. Today's episode is brought to you by our sponsor, ANAFLASH. Silicon Valley startup ANAFLASH announced that it acquired another startup, Legato Logic, a few weeks ago. ANAFLASH uses non-volatile memory for its compute and memory-based AI microcontroller chip and its IP offerings. Meanwhile, Legato Logic had been working on time-domain computing memory technologies. Both were looking at low-power and ultra-low power applications like on-device AI and battery-powered sensors. Following the merger, ANAFLASH now offers both compute near flash and compute in flash technologies that can be integrated in a standard logic or NAND flash process without any process modification. I'm very pleased to welcome both Peter Song, CEO and co-founder of ANAFLASH, and Shahzad Naraghi, CEO and co-founder of Legato Logic, onto the show to talk about their reasons behind the merger and what their vision is for the future of the combined company. Here's my conversation with Peter and Shahzad. Okay, Peter and Shahzad, welcome to the show. We're going to be talking about the merger between your two companies and the combined vision that you have for the two companies, or for the new company today. To set the scene, both of you have separately been working on these technologies for AI acceleration. Perhaps we could start with some information about each of your companies and the background here. Peter, let's come to you first. Peter, tell us about ANAFLASH and then how you got started.
Thank you for inviting us. Root of the ANAFLASH actually originated from my PhD study at University of Minnesota. It was about the non-volatile memory technology that can be built using a standard logic process. Since the technology can be efficiently integrated in a generic logic processor to store and/or process the AI, I decided to commercialize it and started ANAFLASH.
Okay, so Peter, what kind of technologies do you offer for AI acceleration and into what markets?
Thank you for asking. I believe the most critical requirement of AI hardware, especially for battery-powered edge devices, is low power for storing and computing data. ANAFLASH first provides a non-volatile memory technology that can store the trained AI model parameters without consuming power consumption. And we provide a low-power compute engine tightly coupled with the non-volatile memory technology. Following the recent integration with the Legato Logic team, ANAFLASH now uniquely offers both compute near flash (CNF) and compute in flash technologies that can be integrated in a standard logic or NAND flash process without any process modification. With these differentiated technologies, we are focusing on the low power and cost-effective smart sensor market for now.
So what stage of commercialization are you at with this?
ANAFLASH has proved its logic-compatible non-volatile memory technology IP, so-called Logic eFlash, in multiple generations of process node and foundries. Now, we have a customer integrating the IP in their product, targeting the healthcare wearable market. And also our non-volatile AI microcontroller unit called SMUE samples are currently being delivered to our customers, and we are observing very interesting use cases running from our product.
That's great. Let's ask Shahzad. Shahzad, you're a co-founder of Legato Logic. Tell us a little bit about the idea behind Legato and how you got started.
Thanks, Sally. Thanks for having me. Our journey started with a passion for smart sensors. We noticed the real gap in the market, that there weren't just enough intelligence sensing solutions, even though the demand was there. And we both had the ideas and the technical expertise to do something about it. And as we explored the space, we realized that a lot of sensor data was being processed inefficiently. For example, they were sent to the cloud. And that led us to the key idea that what if we could embed AI processing directly within the sensor and right at the edge before the data gets transmitted or further processed. This was actually inspired by the human nervous system, where reflexes allow rapid responses without involving the brain. So we proposed a reflex-like approach to computing. With an always-on and ultra-low power edge AI processor, we monitor and filter the data intelligently, and we send only critical and relevant information to the cloud or a more powerful processor. And to make this possible, we developed a mixed signal AI processing engine based on time domain signals. We taped out the proof of concept in a very short amount of time, built the compiler and got back the silicon, and successfully tested machine learning models on our chip.
Oh, that's very exciting. I know you said it's based on time domain signals. Why time domain, and what does that really mean here?
Well, there are many advantages coming from the time domain processing. It allows for self-timed and self-stitched system that can stay stable despite variation. It also enables greater usage of digital circuits, ultra-low power consumption, and even operation in the sub-threshold regions. And time domain signals also allow for a wider dynamic range generally, and also more power efficient digitization. For example, we can eliminate ADCs and DACs that are common in some analog IMC methods, and we can have lower power consumption and even better parallelization. So this allows bringing AI to resource constrained sensor environments.
Peter, why did it make sense for ANAFLASH to acquire Legato or for the companies to merge?
When I first heard the Legato logic pitch from Shahzad at our common investor event, Berkeley Skydeck Demo Day back in 2021, I initially felt that Legato could be a strong competitor in our domain. Then ANAFLASH also started looking at the time domain-based approaches that Shahzad just mentioned. Eventually, we learned that using a time domain-based approach has many benefits than the conventional other analog domain-based approaches. For example, our university research collaborators at KAIST recently presented their findings at IEEE conferences. Also at the TinyMS Summit held in 2023, the Legato Logic team also presented a paper about its patent pending time-based work. And I started thinking about how to collaborate, not compete with them at the moment. And indeed, I was able to meet several investors actually who identified us as a competitor, but to be complemented each other.
Oh, that sounds great. Shahzad, in the combined company, you're now the CTO of ANAFLASH. What does the technology roadmap for the combined company look like?
So Legato's technology is also standard CMOS logic compatible and also memory agnostic. And as Peter mentioned, ANAFLASH was already a part of our investors' portfolio, Berkeley Skydeck, and they were working on a fascinating non-volatile memory technology for low cost and low power applications. Also, ANAFLASH was developing AI processing optimized around their own memory. So the synergy was clear. We had complementary technologies and a shared vision. So we decided to join our forces together. So now our plan is Legato Logic's technology will be combined with the ANAFLASH SMU and SMU-N products, and we will continue to improve our technology under ANAFLASH. Our technology will serve as a core IP integrated in our combined product, and we can also provide a complementary solution to other chip makers as well.
Peter, what kind of applications are you hoping to target with your combined portfolio now? What kind of benefits do you want to bring, and what do you see as the trends here?
Coming back from my recent trip at the Edge AI Foundation Summit, I observed that various battery-powered edge devices actually now start adapting edge AI from the device. Also, there are growing concerns about the security matters, such as model stealing. And interestingly enough, TinyML was even demonstrated to detect a counterfeit chip. I'd like to emphasize that our logic flash technology can be integrated securely into our processor chip to store security key. With our latest work presented at the summit, we configured the logic flash technology as a main memory tightly coupled with the AI compute engine securely, and then also reducing data movement for battery-powered AI MCU applications. And also, there is another interesting trend using flash as a cost-effective and power-efficient alternative to DRAM for AI inference from the edge devices. With the growing interest in running generative AI from the battery-powered devices, I'm glad to see potential industry partners coming aboard to bring computation close to where the AI model is stored, which is actually flash. ANAFLASH pioneered this direction since 2019, and its technology was recognized as the best prototype award at last year's TinyML Summit. We are also working on a more advanced version of the AI processor technology using NAND flash called SMUN for larger AI model acceleration from the edge devices. So if anyone wants to learn more about our current offering, and please consider attending our talk about AI MCU featuring a standard logic compatible eFlash, which will be presented at IPSOC later this month at Santa Clara.
Thank you, Peter. I think to finish, I'd like to ask you both, what's the vision for the combined company in the longer term then?
Our long-term vision is to pioneer reflex computing in smart sensors through our ultra-low power AI processors. By combining our technologies, we are developing a next-generation product with the goal of increasing the power efficiency even further. And this will enable smarter, more autonomous edge devices that can process information intelligently with minimal energy, and will make AI power sensors more sustainable and omnipresent.
So adding more comment here, ANAFLASH is here to support edge AI developers, partners, and also customers who are interested in running AI models ranging from TinyML to Gen AI on battery-powered edge devices. ANAFLASH shall be a key enabler of low power and low latency AI deployment from the battery-powered edge devices by scalable, non-volatile AI acceleration solution.
Thank you both very much for joining us today.
Thank you.
Thank you.
Thank you very much, Peter and Shazad, for the intro to ANAFLASH and Legato Logic. This episode of AI with Sally was brought to you by ANAFLASH. Thank you very much, ANAFLASH, for sponsoring us. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles and topics we've discussed are shown on your left. AI with Sally is brought to you by AspenCore Media. The host is Sally Ward-Foxton, the producer is James Eade, and our project manager is Colleen Heckman. Thank you for listening.